水稻是中国和世界最重要的粮食作物之一。据不完全统计，全世界共有120多个国家种植水稻，超过一半的人口以稻米为主食。随着全球老龄化进程加快，农业劳动力面临着严重的短缺问题。老人、妇女和儿童成为了部分农村地区农业生产的主力军。未来谁来种地，成为了困扰中国和世界农业的一大难题。为破解这一世界难题，2020年，中国工程院院士、华南农业大学教授罗希文率领团队在广州建成了世界第一个水稻无人农场。2020年，华南农业大学水稻无人农场正式启动建设。第一个环节是旋耕，无人驾驶的旋耕机自动从机库开出，自动开到田中，在第一行作业的起点将旋耕机放下来，开始作业。在北斗卫星信号和计算机的支持下，精准地完成走直线、掉头转弯和对行上线等各个动作。直线行驶误差不超过2.5厘米，对行误差不超过3厘米，可以保证不漏耕、不重耕。第二个环节是播种，无人驾驶拖拉机配备水稻旱直播机，采用开沟旱播的方式，准确地将稻种播在田中。第三个环节是田间管理。水稻生长期间，采用无人驾驶高地系喷雾机喷施农药，利用无人机进行农药喷施和变量施肥。第四个环节是收获，无人驾驶收获机和无人驾驶运粮车先后自动从机库驶出，组成无人驾驶主从导航收获系统。收获机自动进入田中收获，运粮车在田边等待。收获机粮仓快满时，通过云端服务器向运粮车发出一个请来接粮的信号。运粮车收到信号后，立即开到收获机旁边，收获机准确地将稻谷卸至运粮车中。卸完粮后，收获机继续收获，运粮车判断自身粮仓是否装满，若不满则原地等待，继续接收请来接粮信号，若满则将稻谷卸至卡车中。经过测算，无人农场的水稻产量达到了662.29公斤每亩。华南农业大学的首个无人农场实现了5个功能：一是耕种管收生产环节全覆盖，即覆盖农作物生产中的耕整、种植、田间管理和收获的各个环节；二是机库田间转移作业全自动，即农机自动从机库转移到田间，完成田间作业后自动回到机库；三是自动避障一况停车保安全，即在农机转移和作业过程中能实现自动避障，遇到异常情况能自动停车，以确保安全。四是作物生产过程实时全监控，即能对作物生产过程中的长势和病虫草害情况进行实时监控。五是智能决策精准作业全无人，即能根据作物的长势和病虫草害情况，及时做出决策并自动进行精准作业，包括精准施肥和精准施药等。2020年至2021年，罗希文院士团队在全国11个省启动了20个无人农场建设，其作物类型包括水稻、小麦、玉米和花生等。无人农场为解决谁来种地提供了一条有效途径，必将引领世界农业进入数字化、智能化的新时代。
Hello everyone, I'm Zhiyan Zhou from the Key Lab of Agricultural Artificial Intelligence and Engineering Research Center for Agricultural Aviation Application, South China Agricultural University. My topic is application of UAVs in intelligent rice planting. As you can see in these two charts, in the past 7 years, the agricultural UAVs industry in China has grown rapidly. By the end of 2021, China had more than 180,000 agricultural UAVs, and the UAV application in agriculture had reached more than 10% of the cultivated land area, about 100 million hectares. This map showed the proportion of cultivated land treated by agricultural UAVs in China. We can see that most regions are using agricultural UAVs for agricultural spraying application, especially some provinces in East China and Northeast China. For example, 80% of the cultivated land in Xinjiang and Heilongjiang province used the UAV. Of course, there are many other applications for UAVs in agriculture besides the spraying. As for the intelligence, simple and flexible, UAVs are used in nearly all kinds of crops, such as cereal crops, orchard, and timber trees. So, why we choose the UAVs? First, I'd like to talk about the main features of agricultural aviation technology. Here, I have summarized 4 points. High efficiency and quality, wide adaptability, low cost, and strong ability to deal with sudden disaster. As a dark horse, UAV has brought new opportunities to agricultural aviation. It is interesting and encouraging that the agricultural UAVs have attracted many young people to go into agriculture. This thanks to the intelligence, labor saving, and the portability of UAV technology. In other words, people can wear leather shoes to farm. That may sound a bit ridiculous, but that's what happened. In future, the agricultural production will become more time-saving and labor-saving. So, how the UAV promote the intelligent farming? Here a case showed that how does UAV used in intelligent farming of rice in China. 3 sections are involved in the farming chain, including digital sensing, intelligent decision, and precise farming. By using these key techniques, automatic irrigation, efficient plant protection, variable rate fertilization, pollination, and rice direct seeding are becoming possible. The first one is automatic irrigation. The remote sensing UAVs are used for acquiring the images to analyze the water layer height and soil moisture in paddy fields. Besides the UAVs, ground-based wireless sensor network is also useful for the automatic irrigation. Combining the UAVs and the sensor network, it is possible to make prescription maps for automated irrigation decisions. The second one is about variable rate fertilization. Our team has developed a technical system for variable rate fertilization by UAVs, including low altitude remote sensing, analysis of nutrients, and fertilization decision. This slide shows some common UAV remote sensing platforms and its operation efficiency. The maximum can reach 870 hectares in a single flight. However, traditional processing of UAV acquired images will take a lot of time. For example, 67 hectares of a field was observed by a normal remote sensing UAV. 5,000 images will be acquired, and the processing time for these images needs about 5 hours. That's too slow. Fortunately, researchers have noticed this point and made many attempts. A fast analysis method for growth information has been developed, and the amount of the analyzed data can reach about 534 hectares in 1 minute. And how to use the remote sensing images is important. 2 steps. We first process the raw images to generate the orthophoto with NDVI and other vegetation index. Then we applied the remote sensing information in the developed decision support system for rice precise farming. According to the remote sensing information and the decision support system, the variable rate fertilization prescription maps can be created. This slide showed the comparison of effects before and after variable rate fertilization by UAV. It can be seen that through the precise regulation of variable rate fertilization, the growth of rice among the various fields is relatively uniform, which is the main reason for the improvement of the overall yield level. This slide showed the variable rate of fertilization in unmanned rice farm of South China Agricultural University. The third one is about efficient plant protection by UAV in rice. As an advanced and applicable tool, UAV has significant advantage in dealing with sudden disaster, the trafficability of paddy field, and the separation of human and farm chemical, and hair work efficiency. UAV plant protection has been widely accepted in rice production. In 2021, UAV plant protection covered rice cultivated area over 90% in Heilongjiang province. The fourth one is about pollination for hybrid rice by UAV. Traditional artificial pollination is laborious, and it is difficult to realize the mechanization for the whole process. This slide shows the pollination UAVs from South China Agricultural University. A single flight can reach about 80 minutes, covering 8 hectares. The last one is about UAV-based short seeding device for rice planting. The developed device can realize 5 rows of simultaneous seeding, 1 hectare per hour. The seeding row width can be controlled with 10 centimeters. After 16 days of seeding, the germination rate was stable, and the average germination rate is 82.63%. There are the current situation and prospects of the agricultural UAVs that I want to introduce to you. Thanks for watching, and feel free to connect me if you have any questions or ideas.